why does the calf muscle requires thousands of pounds, even though it has a second class lever? When you perform this calculation first time, you get shocked by looking at this number that, how, because it's a second class lever, you expect a little bit less for this force needed from the calf muscle to do, let's say, calf raise your whole body. Assume that a person is 200 pound heavy and they're applying, so they have to lift the 200 pounds. So they will have a ground reaction. So they're lifting with the toe, ground reaction coming from the ground, 200 pound, exact same ground reaction. And then the joint force will act in this direction. So F joint. And say these distances are given 1.5 inches, and then this is given 8 inches, and then you're trying to find the muscle force here. So two forces that we don't know. So if you want to calculate the muscle force, you can simply take moment at point this joint, then that will give us the unknown force F. Simply, so we can write Fm muscle force times the distance. That will be same as the 200 pounds, and then it's 8 inches away. So if you solve for Fm, you'll find the muscle force 1067 pounds. So just to leave 200 pounds person his body weight or her body weight without even having anything, it's gonna produce about this much over 1,000 pounds force. And then you wonder, okay, if it's a second class lever, then why this force is too high? You're expecting a little bit less. To answer that question, I'll create a hypothetical situation. Let's move this joint somewhere here. Let's say hypothetically assume this joint is here. So I'm just flipping the distances. So that is 8 inches. Now if you do the same calculation, simply do 8. Simply flip those distances. And then you find the Fm, the muscle force, is only 38 pounds. Almost nothing. Therefore, now you realize it is because of the distances. It is still a second class lever because it's this distance where this joint is. That's why the forces are, this crazily, different or too high. If you calculate the total joint force in this scenario, that would be simply 200 pounds plus these 1,067 pounds. So that's total 1,267. Now you can see you're lifting 1,267 pounds by applying 1,000 pound force. So then now it's probably a second class lever. I want to give you another example. Let's say you're squatting with another 200 pounds. So this force then, with 400 pounds, that's then will become, let me put it in my calculator, is 2,133 pounds if you squat with another 200 pounds. Typically, people can do squat with their same amount of body weight. So with that, you're actually producing 2,000 force using the calf muscle. So simply because of the distances, this force looks too high. So it is still a second class lever, but muscle still needs to produce a ton of forces because the weight is arranged.